Okay. So when this is expanded, okay, so we write as p to the power n. This is a binomial theorem. Okay. When it is expanded, it can be written as p to the power n times p n minus 1 q n minus 1 factorial by 2 p n minus 2 q square and so on. Okay. Now here the probability of failure is equal to 1 minus probability of success. It can be observed that the coefficients of the RPS term in the expression represents the number of ways in which exactly R failures and n minus R successes can occur in n trials. That is, so we can write here for the RF term, it can be written as, write down this, PR is equal to NCR p to the power R 1 minus p to the power n minus R. PR is NCR p to the power R 1 minus p to the power n minus R. Okay, write down where 1 minus p is the failure. Right? P is considered as a success. 1 minus p is the failure. Now what is success? Success, you can consider a generator outage to be success event or a generator in service to be a success event. That depends on you. The other event is the failure event. The event of interest is the success event. The event which is otherwise is the failure event. Okay. Now, therefore, with this expression NCR, the combination expression, we can write p plus q to the power n as a summation of NCR PR q to the power n minus R. Okay. Okay. Did you write this? Okay. Now this summation is actually one. All the outcomes, the probability will be summed to 1. Right? Now we'll come to the problem. Okay. So that we discussed yesterday. We started discussing yesterday. So we'll go to the problems and we'll start with this one. A coin is tossed 5 times. Evaluate the possibility of each possible outcome and draw the probability mass functions and the probability distribution functions. So here that means n is equal to 5. Okay. Now what is NCR? What is the formula that we have discussed? N factorial divided by n minus R factorial. R factorial. Right? So these two first you write these two formulas. Okay, did you write? Then we will evaluate the probability of various events. So what are the events? Coin is tossed 5 times, right? So you can have 0 head, all tails, or all heads, 0 tails, or in between 3 head, 2 tails, 2 head, 3 tails, and so on. So the function of the binomial theorem in this case, or binomial distribution in this case, to give a probability of each of these occurrences. So what is the probability of this occurrence? For example, what is the probability of all heads? Okay. And all these are from this book. So this is the part 1 book of Wellington. Okay. So here it is reliability evaluation. The work of this book ends today. Okay. So only first 3 lessons where we discuss the prerequisites of reliability we have discussed. But this book can be followed in a complete course of reliability. Okay, but it is not our topic. So we have only taken what is required from here, and maybe something else in a small amount we will take later. Okay. This is the part 1 book. From next class onwards, we will discuss the part 2, which is reliability evaluation of power systems. So this is reliability evaluation of engineering systems. The other book will be reliability evaluation of power systems. You need not have this book; it is not required. Whatever is required, we will discuss in the class. Okay, in the library you can refer. We have lots of these books available. Okay. Next we will solve this. All these problems are from this book. All these problems that I have given are from this book. So write down like this. So head is 0, tail can be flat. This is one unit. The expression will be NCR, IC0. R here is 0. We have considered the success to be head. Okay. For our case, we have considered the success to be head. Okay. For our case, we have considered the success to be head. So it will be 5C0, 5C1, 0 success, 1 success, 2 success, 3 success, 4 success, 5 success. Okay. And the formula says, what is the binomial formula? 5C0 success to the power r. That means half to the power r, which is 0. Half to the power n minus r, that is 5 minus 0, 5. Okay. So this becomes, if you compute this only half to the power 5, because half to the power 0 is 1, 5 0 is 1. So this is 1 by 3. Okay. Similarly here 5C1 is 5. You know that 5 factorial divided by 1 factorial divided by 5 minus 1, 4 factorial. That means 5 factorial by 4 factorial, 1 2 3 4 5, 1 2 3 4, so only 5. So this is 5 by 3. Okay. Similarly here 5C2, 5C4, like that. You should be very thorough in computing. Okay. Compute this and write. Okay. So this is known as the individual probability. So it's what it means. It says that what is the probability that for a coin toss of 5 times, there are 3 heads and 2 tails. What is the probability? The probability is 10 by 32. What is the percentage? 10 by 32. Percentage. 1 by 32. 10 by 32. Okay. 10 by 32. What is the percentage? 31%. So 31% or 0.31 probability is for 3 heads and 2 tails. The same probability for 2 heads and 3 tails also, because here the individual probability is half, both are equal probabilities. Okay. Now, as we discussed in the last class, how to form the PDF and CDF. Probability density function and cumulative distribution function. Probability density function simply the number of success versus the probability. Okay. Since it is a discrete case, so only this box you will see. For a continuous case, you will see a curve. The cumulative one is you will simply add up. 1 by 32, 1 by 32. 5 plus 1, 6 by 32. 10 plus 5 plus 1, 16 by 32. 10 plus 10 plus 5 plus 1. 26 by 32. 5 plus 10 plus 10 plus 10, 5 plus 1, 31 by 32. And all combined 32 by 32. The last one for a cumulative probability should always be 1. Okay. So what are the axes here? So axis here is probability. Okay. In this case, probability. Now here the last probability should always be 1. Okay. And here our success is number of. So this is a classical example of binomial distribution. This is question number 1. Did you get it? Because it will be used. Okay. Next. So we'll move to next question. Question number 2. Consider the case in which the probability of success for a single trial is 1 by 4 and 4 trials are to be made. In this case, it's not half, it is rather 1 by 4 and n is equal to 4. So n is equal to 4, p is equal to 1 by 4. So that means q is equal to 1 minus 1 by 4, which is 3 by 4. Okay. So now you evaluate the individual and cumulative probabilities of success. Success in this case is 1 by 4. Okay. And draw the two respective probability functions, that is PDF and CDF. So do it. Do it. Start solving it. First you will write just like head and tail, you will write SF, success and failure. Okay. So you can have 0 success, 4 failures, 1 success, 3 failures, 2 success, 2 failures, 3 success, 1 failure, all success, that means 4 success, 0 failure. So this is the list of the event. So these are the list of the events. The next column will be probability. Right? Next probability where you will write the binomial formula. So for the first case it will be 4C0. How much it will be? 4C0. Success probability to the power 0. That means 1 by 4 to the power 0. Failure probability to the power 4 minus 0, that is 4, which is 3 by 4 to the power 4. Okay. And compute that, make computation for that. Okay, so here all of you have written the first, you write all the probabilities. So you must have written the probabilities. Compute. Okay, compute each one and use the formula n factorial by n minus r factorial. Always remember that there is a very useful formula for computing combination. NCR. For example, I would say 4C2. How to compute? So it is 4 factorial divided by 2 factorial divided by 2 factorial. So it is 1, 2, 3, 4. Okay. Divided by 1 into 2. Again 1 into 2. Right? So this cancels out. Is it the formula? 4 factorial divided by n minus r factorial. Okay, how much is 4 into 3? 6, 12, 6. 6. So always remember that if it is 4C2, you can always write this as 4 into 3. So this 2 is there, divided by 1 into 2. Okay. For example, suppose I say 7C3. So instead of going for the whole formula, I can write 7 into 6 into 5, 1 into 2 into 2. Okay, like this also is possible. Because 3 factorial will be there and 4 factorial will cancel out the 1, 2, 3, 4. Right? So you can easily write it this way. So now we'll see the solution. Okay. so this you must have calculated. This one, second one. So I will written the expressions. The first probability is 81 by 256. Anyone who has got it? Right?
0.316.
Okay, but 81 by 256. Second one is 108, 54. Well, check your answer. And cumulative probability is simply the addition. And you know how to plot the PDF and CDF. Now it is clear. Question number 3 is similar. You can solve it at home. Okay. Next. Now, yesterday we discussed every probability distribution is represented by mean and variance. Now each probability distribution has an expected value and standard deviation. Okay. So for example, I say something follows binomial distribution and I will give you the binomial distribution. How to find out the mean and the variance. So there are analytical expressions for that. So for a binomial distribution, we have used the formula for discrete summation x equal to 0 x px. What is px here? The px is nothing but this formula ncx px q n minus x. So this is the formula. Okay. So when you go on doing the derivation, eventually what you are going to get? You will get the expectations to be np. So write down this formula. So the expectation of mean ex, expectation is also mean is given by np. Whereas the variance is given by, just write down these two expressions. Derivation is not required. The variance is given by np. Okay. So expectations is given by np and the variance is given by npq. Okay. So now I am going to solve example 3.4. Okay. So that will come for our class. Example 3.4. So we will come to the solution later. Just remember that mean is np and variance is np. Okay. Solve. Question number 4. A product is claimed to be 90% free of defects. What is the expected value and standard deviation of the number of defects in the sample of 4? So this follows binomial distribution. That is because there is only successive probabilities. Okay. So what is n here? Number of samples. Number of samples is 4. Okay. Now it is claimed that the product is claimed to be 90% free of defects. That means what is the probability of success? 0.9. So what is the probability of failure? 0.1. Right? Now it says what is the expected value and standard deviation? I know. Give me the answer. Yes.
So जो previous question है उसका second question है. So second जो previous one है उसके लिए होता है उससे.
You check in detail, you will find out. It's the same answer. Okay. Check at home, it will be the answer. Okay. So in case what is the mean? Mean is np. 4 into 0.9. How much is this? 3.6. 3.6. 3.6 होगी number of expected value of, this is not defects, these are actually successes. So we have taken the NP value because it's success. So that means number of values will be 0.4. Right? Number of values is 0.4. So what is the standard deviation? NPQ. So 4 into 0.9 into 0.1. 0.36. So let's see whether our answer is correct or not. that is variance. Whatever you have got, that is variance. So for standard deviation, you have to take the root of variance. Okay, so it will be 0.6. 0.36 was there, 0.6. And this we found to be 0.2. Right? Okay. Or this is the way we use the formula to find the answer. This is the way we use the formula to find the answer. Okay. Otherwise, you can simply go on doing your probability. Okay. What is Ex? X into probability 0. 1 into this, 2 into this, 3 into this. Okay. Then you know, right? The mean can be found out to be X Px. So X is to Ps. Variance is, okay, there is a formula for that. We have discussed expectations minus, there is a formula. Okay, using that formula you will find out it and add it up, and the same result you will get. Okay. And this is the one we will be using in some module of RPS. Okay. Now, next two problems we will discuss. I have not given the solution, it is for you to do it. Question number 6 and 7. Consider a system of 4 identical components with success probability 0.9, failure probability 0.1. Compute the total number of states. Evaluate the probability of states in which the components can exist. States means how many failures, how many success. That probability you will find out. Okay. Reconsider the above question but introduce additional aspect of component rating expressed in percentage of the required system output. Okay. So you have to, for this you have to think a little bit. Okay. This is not required as such. These are only for your thinking, so that you can explore reliably. As usual, if you Google it, you can find the answer. Okay. But before that, just explore. Okay, what the problem is. So it's not necessarily a numerical answer, only for you to explore. Okay. So that completes our discussion of binomial distribution, and now we will go through some more things from the book.